PyNet Labs, and my name is Jatin, and I'm going to be your instructor for this CCNA demo session. So we are going to discuss about the CCNA program, and basically we will be discussing as in the fresh part or from the scratch part that what exactly and how we are going to cover up the entire training and what are the syllabus accordingly we will be discussing, which is there as per the official blueprint. So I'll not take much time when discussing the exam overview. So you can do check. We'll share the link for the exam overview. So you can do check that on. So let's get started. Let's don't waste much time. So as of now, the demo session we are taking is on CCNA 200-301. So you know that in this CCNA 203-301, it is all about enterprise. And the thing we call it as enterprise because what used to happen previously, there were specific certifications for every CCNA. Like if you're going for security, so there was CCNA in security, there was CCNA with collaboration, so many certifications like that. But previous paper code was all about routing and switching. But now in this paper code, which is 203-301, it is considered as enterprise. And in this enterprise version, why we call it as enterprise? Because it is a combination of routing and switching. There is some information about, you can say, automation. An introduction for automation is there. So we are definitely going to discuss the automation part, as well as there are some topics which are related to architecture, like what is spine tree, what is two-leaf topology, three-tier topologies. So all these things are included in this particular CCNA training. So it's not like we are directly going to start with the routing and switching. We are going to start with very basic things like network fundamentals. And in the network fundamentals, it's like there are many topics like OSI model, TCP/IP model, IP addressing part, so many things like that. So that's the official blueprint which we basically follow. So we initially start with the network fundamentals. Then after discussing the network fundamentals, where we have TCP/IP, OSI model, IP addressing, subnetting, even though it is there with the labs. So then we move towards the network assurance part. So in the network assurance part, basically we have something is your services, like you can say architecture discussion is there. What is the topology? What is three-tier topology? What is two-tier topology? And all these things. Then we have IP connectivity. So in IP connectivity, we basically discuss the things like what exactly the DHCP server is, how you can implement DHCP in the real-time production environments, as well as what are the specific services like some topics like network address translation. And very interesting thing about network address translation, suppose that as per the official blueprint, if you will see that there is a topic which is network address translation. So if you have an idea that this network address translation is divided into three categories, we have static net, then we have dynamic net, and there is one more which is port address translation. So currently, as per the official certification, only the port address translation is there in the official certification. But we in PyNet Labs, we basically discuss this static net. We are going to discuss this dynamic net as well, because as per the production scenarios or as per the production requirement, you must be having a good idea on the older concepts. Like suppose if I say about the routing protocols, so majorly OSPF is discussed, EIGRP is discussed, but there is one more protocol which is RIP, and with the RIP as well, you will find version 1 and version 2. So two versions are there, but nobody discuss about the RIP protocol because it is being obsolete, or you can say it's not really used in the production environments. But many interviewers can ask you questions from RIP protocol as well, that what's the difference between version 1 and version 2. So no worries about these things. Like we basically in PyNet Labs, we cover the complete CCNA training, like the way a network engineer must have good understanding about the topics, even though those topics are not there in the CCNA trainings as per the official blueprint. But yes, for sure, we are going to cover up those topics as well. So these are some prerequisites or overview, you can say. Then after moving towards the IP connectivity, we talk about IP services. So a lot of things are there with the IP services like subnetting and so many things related to IP addressing part. So basically we don't cover that part up to the services. We cover in the network fundamentals, because to move over the initial things, you need to understand the basics first. Then, the best part about the CCNA training is that now we have some security fundamentals as well. So as per the official blueprint, you will find that it is mentioned as fundamentals, but it's not fundamentals. Here we are going to cover up layer 2 security. We'll cover up layer 3 security. We'll see the differentiations, and there is some introduction of wireless networks as well. So labs we are going to discuss on the wireless networks, and apart from that, lastly we do discuss the automation part. So in the automation part, it's not like that it's an introduction or an overview for your to understand the automation, but with the overview, with the introduction, we will just show you some labs that how basically automation is going to work and how it's helping the network engineers to process things faster in the real-time production environment and what's the need of automation. So this is how we are going to cover up. So initially we'll be starting with the fundamentals, then we will be discussing the switching part, then we will be moving towards the routing part, then we will discuss the services related to IP connectivity and fundamentals of security. We will be discussing where all the security part using the layer 3 device, using the layer 2 device. Layer 3, if I say layer 3, so there are two layer 3 devices. First is we have multi-layer switch. So over this, I'll show you some labs and we have router as well. So we'll be discussing the layer 3, both of the devices using the security. Layer 2 is something switch. So there are various features which needs to be enabled on the layer 2 devices. So that is something. And with the wireless networks, I'll be giving you the good idea about how you can deploy wireless network inside the production environments. What are the wireless devices which are used, and after using those devices, there is an introduction as well that how you can secure your wireless networks, because up to this part, if you will see, up to the security fundamentals, it is all about the wired networks. But when we will be discussing the wireless deployment part, there we'll discuss that by deploying the wireless networks in the production environment, how you can make it more secure, what are the algorithms which are used to make the wireless network secure, and what are the terminologies to understand the wireless network. And lastly, we have the automation where we'll discuss how basically the automation is being used in the production environments and how basically we are going to create the automation labs and what are the requirements to go with the automation. So this is how basically we are going to start our CCNA journey. Now I would like request every one of you that in case if you have any kind of topic, if you want to make sure that you want to have a demo session on that particular topic, so you can use the chat box to write your topic, whichever the topic you would like to have in demo session. Then accordingly we will be proceed towards the lab or the demo session so that you guys can have a better idea that how and in what way we are going to cover up the entire CCNA training. So you can use the chat box for any topic, whichever the topic you would like to discuss in the CCNA demo session today.
All right. So which part of topic we'll cover? Subnetting. Okay. We can use subnetting would be to, if you have basic idea about IPv6 and everything, I think we can start subnetting in this. Any topic that Jatin you would like to cover, which people with no experience or freshers will be able to understand?
Yep, we can go with a lot of topics are there. We can go with security. We can go with IPv6, which is pretty much new and that is being introduced in CCNA as well.
Okay. Can we take up NAT or subnetting? I mean, the major concern is, will Rakesh, Anurag, do you have experience already? I'm just giving you an unmute access. If you could speak a little bit also. Yeah. Anurag, you can unmute yourself and speak. I'm giving access to Rakesh also meanwhile.
Could you hear me?
Yeah, we can hear you, Anurag. So what's
All right.
your experience like? Yeah.
Well, I mean, I have done CCNA training a long time ago, probably back in 2003 or 4. So again, I started it. I kind of end up not doing it, and since then, I'm basically working as an enterprise implementation manager, where I do different application installs within the organization. So managing the exchange servers, kind of back office technologies. Now I would like to get more into the CCNA, and I know recently they introduced quite a few things within the the course, and I mean, my main concern is I really wanted to go back and refresh whatever I have learned. So, and I know they introduced new stuff in the course, so definitely like automation wasn't there back then. Uh, I believe wireless network. I don't remember if I have done that anything like that before in that previous course, but yeah, I mean, definitely would love to learn about the new stuff. And the challenging part for me that time was subnetting, and that probably the one thing where I kind of um, don't have much information. So
Understood. Makes sense. That's fine. So, okay, got it. So good to know that your next journey would be definitely fruitful. You're starting CCNA once again, and I'm sure I'm hopeful that you'll go to next levels as well, and grow your career as well in the same. So actually, what happened was, Anurag, a small thing. We took up this subnetting topic in the last session last Sunday also. So what happened in that was, a lot of people who were freshers in that session, there were, I think, 25, 26 people in that session. So nobody was able to understand things. Reason being IPv6 has to be revised and a lot of other things has to be revised. If everybody else is good to go with subnetting, just mention yes, we'll start with subnetting then. Okay.
I mean, I'm not looking for you to explain subnetting right now, because
Okay. All
it
right.
can get very. I
Tricky
know
and
what
yeah,
subnetting is, but it just my my
expectations from the
yes,
session.
my understanding or my expectation is from that. Let's say if I go ahead and join the course, I would like this topic to be covered as well, because that's where I kind of feel myself I'm little kind of fall behind.
No problem.
So
That's fine. But you'll be able to do it. No problem. That's fine.
sure.
Okay. So thank you. Okay, so we'll start with Jatin. You choose any random topic you want to choose, because the objective of demo session is mainly that how you'll be teaching will people would be able to understand your way of teaching and your Q&A and everything. So that would be good. Yeah, just we can start with any session, any topic that you would like. Even if you want to start with subnetting, that is also fine.
Okay, all right, I got it. So what we can do is I really suggest everyone here in the CCNA demo session that if we'll be going with subnetting network address translation, so we need to understand the iOS part about the devices, that how these things are going to work in the devices and what are the command executions. So that's pretty much lengthy for freshers to easily, like they'll not get at the topic. So what I suggest, we can go with IPv6 and we can have a lab as well with the IPv6, and I'll be giving you a glimpse about IPv6, that how IPv6 is being deployed in the production environments and what are the prerequisites which we need to learn about IPv6, because it's being something new which is being deployed in the real-time networks. And with this, we can just basically discuss the overview as in comparison with the V4 and V6 as well. So that's my suggestion. So we can go with IPv6.
Done,
So
Jatin.
let,
We can start with that. Yeah,
yeah,
sure.
all
Thanks.
right, thank you. So let's get started with guys IPv6. And this IPv6, like we know that this is a new thing which is being released. And right now, if you will see that many of the telecom operators in India and in apart from India as well in the global level, if you will see, everyone is being deploying IPv6. And it's very, we can say the next version of IP addressing, which was released after IPv4. So just to give you a glimpse about IPv4, let's talk about V4 first. What exactly V4 was and why do we need V6? So when we say this IPv4, we know that this IPv4 was of 32 bits, which in total, like it was written in the format decimal. And in total, if you will say that how many total addresses were there in the IPv4, so 32 bits were there. So if I say 2 raised to power 32, so it was something like 4.3 billion addresses were there. So now we know that the population of the complete globe is like more than 4.3 billion. So we will not able to survive on IPv4 addresses. Like now these days, if you will say that in single family, like there are, suppose for an example, if there is a family and in the family there are 4 people, so we know that there will be definitely more than 4 devices which will be using IP address. So in just a family, if 4 people are there and they are having 5 or 7 devices which are using IP address, so it was pretty much difficult to survive on IPv4. and we were running out of the IPv4 addresses. So just to make sure that there should be something which can be helpful to save the IPv4 address, there were some possible solutions which were created to save IPv4. One of them was your subnetting. Then second was your network address translation. So these were two possible solutions which were announced before IPv6 just to make sure that we can still use IPv4. And even today also, if you will see the subnetting and network address translation, both of these things are there in the production environments. And just because of these two features or protocols, we can say we are still using IPv4 in the real-time production environments. And there is something that after this part, still like, as you know, the network was rapidly increasing and it was growing rapidly. So we would not be able to survive on 4.3 billion addresses. So to overcome this, IPv6 was announced, which is an advanced version. And we know that IPv6 is total of 128 bits and it is written in the hexadecimal format. So when we say hexadecimal, it is something like it is going to have some values or alphabets from A to F. And if I say it's gonna be 2 raised to power 128, so in total, we are going to have some addresses and trillions where every single human can have one single IP and still we will be able to use IPv6 up to 30, 40 years more. So it's not like that we will be run out of the IPv6. So because it's just simply going to provide you a very large address space just because it is of 128 bits. So we can say a feature of IPv6 that it's going to give you a large address space where every single human on earth can have one single IP and still we will be able to use IPv6. Will not run out of the exhaustion of IPv6. And in most of the telecom operators and many of the production deployments, I have seen that they are using IPv6 now these days because here in IPv6, we say that no need of broadcast. So there is no broadcast as well as no network address translation is needed. But this point, when I say no need of network address translation, when IPv4 was announced, there was no need of network address translation in IPv4 as well. But just to save the IP addresses, we have to implement. But similarly, the same thing is with IPv6. As of now, we don't need network address translation in IPv6. So basically, and even though like we are not going to have any kind of broadcast as well, and it's going to have a very simplified header, which I'll be explaining you with a structure that how basically this is going to look like. And now in case of IPv6, when I say, like if you guys know about IPv4, in IPv4 we have some classes, like we have class A, we have class B, and similarly C, D, and E. So these are the classes which were there with the IPv4 addresses, which were having some range. Like if I talk about class A, it starts from 0 to 127, B starts from 128 to 191, C starts from 192 to 223, and D starts from 224 to 239. So like this was the range we were having. And it was like 240 to 255. So like this, these were the ranges of IPv4 addresses, which basically like we are usually going to use A, B, and C in the production environments. Class D is basically used for multicast purposes. So that is something, and E is not being used. It is reserved for research purposes, which is basically being used by NASA and all these things just to put some operations and do the research on that. But when we talk about V6, in IPv6, we basically don't have these ranges like 0 to 127 like that. So basically we have some address types here. So there are three types of addresses which basically we will be discussing in IPv6. The very first we have is unicast address. Second we have is multicast. And third one we have is your Anycast. Now, when we'll be discussing this any unicast, this is categorized into three more subcategories. Multicast is nothing but it is similar to class D of IPv4. And Anycast is something which is different than broadcast. So I'll let you know with an example what exactly this Anycast address looks like and what's the use of this Anycast address. But before that, I'd like to show you that the structure of IPv6, that how it is written and how we are going to define the IPv6 address. So let's take an example. If IPv6 structure I'm going to define, that how exactly it looks like. So let's take an example. Let's say we have an IP address which is AB0000CD, and we have 1 2 3 4. Okay, not 1 2 3 4. This side I'm going to use some, let's say 1 2 3 4 zeros, 1 2 3 4 zeros again. Then after this again I'll write the IP address. Let's say we have some values like let's say DB01. Again we have some continuous zeros. There is a reason I'm using these continuous zeros because I would like to show you that how we can make it more shorter and how we can deploy in the production environment. So this is 4 times 0. Then again I'll write the IPv6 address, which is 1 2 3 4. So now as you can see guys, this is how the complete IPv6 address looks like, and it is always written in the format that is hexadecimal. So if you don't have idea about hexadecimal, it is nothing but the values starts from 1 to 9. Then after 10 is considered as A, 11 is considered as B, 12 is considered as C, 13 is considered as D, 14 is considered as E, 15 is considered as F. So this is how it is written in the hexadecimal format. So no worries if you are not getting this hexadecimal. We basically do discuss all these things from the scratch part in the live classes. So as of now, just assume that this is a IPv6 structure. Now, in this IPv6 structure, guys, we know that it's written in hexadecimal. Apart from that, this is in total of 128 bits, which I have already mentioned on the previous slide, that IPv6 address is of 128 bits, and that's how it's going to provide us addresses in trillions. And when I say 128 bits, so 128 bits, how it's going to add those 128 bits? Suppose that this AB00 is there. So this complete octet, if I'm talking about, so in total, if you will see how many octets are there, 1 2 3 4 5 6 7 8. So there are 8 octets, right? Where we can say one octet is equals to 16 bits. So technically, if you will say 8 into 16, you are going to get 128, which means to say that this is total of 128 bits. And now from this 128 bits, similarly, like in IPv4, we have some, you can say like, network portion, we do have some host portion. So in this as well, we are going to have some network and host portion. So the first 64 bits and the last 64 bits. So I'll say the first 64 bits is equals to, these are considered as your global prefix value. Global prefix value is nothing guys, but this is something we consider it as the network portion of IPv6. And similarly, when I talk about the last 64 bits, so this last 64 bits are the interface ID, or which you can say as the host portion as well. So that's how we are going to deploy this, IPv6, and we need to understand this as well. Like when I say AB00, so this AB in total, it is consist of 16 bits. And how 16? Where A is going to have 4 bits, 1, 2, 3, 4. B is going to have 1, 2, 3, 4, and then 0, 0 are there. So these zeros will be again having 1, 2, 3, 4, 1, 2, 3, 4. So this is how we are going to say. And if I'll be talking about A, so the conversion of A in decimal is 10 and B is gonna be 11. So 10, 11 like this, all these things we basically discuss in the live classes, but I hope you got the concept that how it consists of 16 bits, and inside one octet, there are total 16 bits where one single number or one single value represents 4 bits in total. Now, talking about making it shorter, how we can write IPv6 address shorter. So to make it shorter, we can just reduce the number of zeros by using colon here. Now I'm saying reducing the number of zeros. So let's say it is written AB00. It's not like that. To make it shorter, you are going to write AB only. So the device will not understand. If the zeros are after, then you need to mention. But now see, this side we are having zero zeros. So you can simply write CD here. Then putting colon, we have four continuous zeros. Instead of writing four zeros, you can write one single zero colon, one single zero colon, and then again we have DB01 and colon 0 colon 0 colon 1 2 3 4. So this is one way of making or writing the IPv6 shorter, where you can just write one single zero instead of using all the four continuous zeros, which means to say the device will automatically understand that there are four continuous zeros. And if you are writing CD here, so the device will understand that priorly before this there are two values which are considered as 00. But that's one way of writing or making it more shorter. If I say AB00, then we have CD. Now you have continuous zeros in the third octet and in the fourth octet. This one, this is the third octet, this is the fourth octet. So what I can do is to make it more shorter, instead of defining this third and fourth octet, I can use double colons here like this. Now the device will automatically understand, if we will write double colons here, that there is something that all the 8 bits are 000. Now, apart from that, rest of the IP you will be writing like DB01. And again, here you are having 00. So it's not like you will be using double colon here as well. You are not allowed to use double colon twice in the IPv6 address, which means to say you are only allowed to use double colon once in the IP. Using the double colon twice in the IP is not allowed. And apart from this is how we are going to make it more shorter. So that's what one thing about the IPv6 structure. I hope pretty much this is pretty much clear to every one of you. If you guys do have any doubts, you can raise your doubts on the chat box as well. Meanwhile, I'll explain you the next thing, which is the types of addresses, that how the types of addresses and how we can identify that this range belongs to IPv6 public address. There is some private IP. So how we are going to define all these things. So that is something which we'll see in the next part. We have types of IPv6 addresses. So if you will be, you can write AB as the AB only, but it's not recommended to write that 00 as well. So it's better like you will be using AB only, or if you will be writing 00, the device will also understand. But you don't need to mention like, these 00s after that. But it's all about having the zeros previously before the IPv6 address. So that makes sense, I hope. Now talking about the IPv6 addresses, there are three categories in IPv6 address. So I'll create a table to like explain you in short, like we'll not be discussing more in detail because a lot of things are there with specific these addresses. So I told you there are three major categories of IPv6 addresses. We don't have classes here. We have address types here. So we have something, first address type is unicast. Second is your multicast. And third, basically, we have is your Anycast. Now, when I say unicast, multicast, and Anycast, unicast is nothing but unicast is a normal IPv6 address which can be assigned to any of the device. But here in the unicast specifically, there are three categories. The first category we have is global unicast. Second category we have is unique local address. And last we have is your linked local address. And when I say multicast is nothing but it is similar to D class of IPv4. And Anycast, I'll explain you with an example. So when I talk about the global unicast, what exactly the global unicast represents? It is nothing but global unicast is something that it is the public IP of IPv6 address. And this one, unique local, that's the private IP. And when I say linked local address, this linked local address is basically nothing, but this is something a by default address. Suppose that if you are having a router, this is your router number 1, and on this router there is an interface which is FA0/1. So on this FA0/1, if you are going to execute any IPv6 address, so automatically after the execution of IPv6 address, there will be a linked local address. So this link local address is a default address which is enabled on every IPv6 interface which you are going to configure. So this link local is basically used for processes like neighbor discovery. Like similarly, we have ARP in the IPv4. So we have some NDP and all these things in IPv6 as well. So link local is just a default interface, or you can say a default address on every IPv6 enabled interface. Now, as of now, guys, you can see that I have told you and written here on the notes as well that these are the types of IPv6 addresses. Unicast is having global unicast, link local, and this unique local. So I'm saying this is public IP, this is private IP. So there come some questions in your mind that how we will be identifying that this is gonna be my public IP, this is gonna be my private IP. So there should be some number or there should be some ranges for that as well. So how we will be identifying that? Suppose that if I'm talking about the global unicast, so I'll use my next page for that. The very first we'll be discussing is the unicast. So in the unicast, the first we have is your global unicast. And what I said about global unicast, that it is considered as the public IP of IPv6. Public IP in the sense this is routable IP, which is basically used to make the communication over the internet, and it's routable as well, which will be executing over the WAN interfaces only. So how you will be identifying that this particular IP is a public IP or private IP? So any IP in IPv6 starts from 2000 /3, which means this is the reservation. As per INA, any IP starts with 2000::3 will be considered as your global unicast IP. Now, what exactly the /3 is? So I'll say /3 is equals to, these are reserved bits by INA. So INA has defined some reservations for /3, where in the /3, the first 3 bits will be like the last 3 bits will always remain as constant. So this /3 will give you 001. Now let me give you an example for that so that rest of the other IP addresses you will be easily able to understand. So if I say there is an IP address which is given by INA and the range given is 2000:/3. Double colon means continuous 8 times zeros are there. So forgot about the 8 times zeros. If I'm going to convert this value of 2000, so let's say there is an IP given to me which is 2. So we know that inside this specific 2 there are 8 bits, 8, 4, 2, 1. So if I'm going to convert this into the format of binary, so I'll get the conversion like C. 8 is not there, 0. 4 is not there, 0. 2 is there, 1 and 0. So 001 is the reservation which is given by INA. And there is a last value which is 0. So as this is one single octet and in the octet only 4 bits are there. So there may be a chance that 8421. So 001. So there may be a chance that this value which is 1 is equivalent to 1 as well. So in case if you are getting this value 0011 0010, so in that case for this part you are going to get the value of 3 because 2 plus 1 3. So we say that any IP starts with 2000:/3 and ends with 3000:/3. That will be considered as the public IP in IPv6 address, which is being identified as a public IP. And apart from that, you can also say that any IP, like I have written here some IP address in the previous section that was starting from AB. So that makes no sense, but that was just an example. But if I'll say 2000, or let's say 1, 2, 3, 4, again 1, 2, 3, 4, 1, 2, 3, 4, and again let's say 1, 2, 4, 4, double colon 1, 1, 1, 1. So this is gonna be my IPv6, and that is gonna be considered as my global unicast IP, and it's gonna end at the range of 3000. So any IP which starts from the range of 2000 double colon slash 3 and 3000 double colon slash 3 will be considered as public IP. Whereas if I talk about this particular IP which is unique local, so it has always start with FC 00 colon slash 7 or FD colon slash 7. So that's the range. And if you want to see the conversion of this IP as well, I can give you an idea on that. Let's say if I'm talking about the second one, that's my unique local. And when I say unique local, it's nothing but the private IP. It starts with FC00 colon slash 7. Now in this case, the slash 7 means the first 7 bits will be constant, which are not routable in the global IPv6 address over the internet, and it is recognized over like by the INA. So if I'm talking about the conversions here, let's say if I want to convert FC is there, and I have already mentioned the same thing in the previous part that 10 is equals to A, 11 is equals to B, like this. So F is equals to 15 and C is equals to 12 in case of decimal values if we talk about. So if I'll say F is equals to 15 and C is equals to 12. Now we know that 8421 8421 because we have 8 bits only. So if I'm going to convert F into binary, so 8 plus 4, 12, 13, 14 and 15. So I'm getting the conversion of 15. So this is gonna be my F value, and 8421 if I want to convert C. So simply 8 plus 4 will be 12 and rest of the other values will be 00. So this is gonna be 12. So FC, we got the conversion. Now as per INA, if you will see 1, 2, 3, 4, 5, 6, 7. So this first 7 slash values will be reserved. Now there is one equivalent value. So if it is gonna be 0, then in that case the conversion will become FD00 double colon slash 7. So that is one thing. And when I talk about the private IP, it's going to have the range of FC00 colon slash 7 and FD colon slash 7. So that is how we basically define all these things. And as of now, like I haven't gone in the detailed conversion things like initially explaining you A, B, C, D, E, F up to F part. So these are like not a big deal as of now because it's just a demo session. But in our live classes, we are definitely going to cover up all these things from the very scratch that you can easily understand the conversion, because this conversion parts needs to be clear before going and converting the IP addresses and getting the ranges of that. And this link local I'll show you on the lab screen. And when I talk about this multicast, the third one, so this multicast is something that it's similar to the class D. So it is always going to start with the range again. So any address which starts from FF00 double colon slash 8. So that will be considered as your D class address, or you can say the multicast address, which is reserved by IPv6 for the multicast purposes. So that's one thing. And when we talk about Anycast address, so Anycast is a very different scenario, which is something like we can take an example to understand Anycast address. Suppose that you are a user, you are sitting at your home and you want to have internet connection. So you contacted your ISP. ISP will provide you one router at your home, and on your router, there will be some gateway, let's assume 192.168.1.100. This is the IP which the ISP has given to you. And normally this is what the home scenario looks like. We have our router provided by the ISP. Then this router is further connected to, let's say, your ISP router. This is your ISP, and then the ISP is further connected to the wide area network. Let's say this is your wide area network. Now over the wide area network, suppose that you as a user, you are trying to access google.com. Now, if you want to access google.com, so in that case, your data will be first transmitted to your home router. Here only the data will be transmitted. Then this router will transmit the same data to the ISP router. Now the ISP will send to the wide area network. And now you know that over the wide area network, if we are talking about Google, so as such, we know that there is not gonna be any single data center of the Google all over the globe. So there are multiple data centers of Google. Let's assume this is one data center. This is second data center. This is third data center. So all these data centers are internally connected with each other and they are sharing their information with each other and maintaining a copy of information and synchronizing the information with each other. So what happens is, suppose that as a user, you are sitting here and basically this is your office location. And to reach on your office, from your home to go on your office site, there are various paths available. So like if I'm talking about the physical locations, so if you want to reach, let's say from Delhi to Pune, so there are various options, like you can go via flight, you can go via train, you can go via your personal vehicle. But what is the best thing every human choose? That the shortest path, that which is gonna be the shortest and which is gonna take less time. So everyone chooses the shortest path to reach on the destination. In the same way, the same scenario is there over the wide area network and in the local area networks, if we are talking about the routing part. So all these data centers of Google are internally connected together and they are being defined in a cluster as well. So this is a cluster, and cluster is nothing but cluster is a term which is used in the server terminologies where multiple physical servers or multiple virtual servers are connected with each other and they are sharing their information with each other. So what happens is on this cluster, there is a virtual IPv assigned. And what exactly we do is we say that this virtual IP is your Anycast IP. Now what happens is that when the user is trying to access the data from internet or trying to access google.com, so from the various multiple servers, whichever the first server will be available to take the, you can say whichever the server is available to accept the request will be able to respond it quickly. Because in case if you are having 100 servers, so it is not like that for all the users you will specifically define that this user will be able to access this data center. Let's say if I am sitting in Delhi location, so for sure if I'm browsing google.com, so it is going to reach on the Gurgaon location. It's not going to reach on the Bangalore location because Gurgaon location is shorter and it will take less time. So on this cluster, there is a virtual IP assigned and that is the Anycast IP. So this Anycast IP, it can be any IP. Like we always say with IPv6 that the IP addresses we have discussed in the last part, global and unique local. The part of unicast category. So both of these IP addresses can be defined as Anycast addresses, which means to say that you can say Anycast address is pretty much similar to your multicast, which is going to identify multiple interfaces over the wide area network, but to whichever it is going to find first, it's going to get the reply from that. So that is what basically the Anycast address is. In just brief, I have explained you this part, but like other discussions are also there, which are like a very lengthy thing. So I'm not gonna take that right now. So that is how we are going to, define the IPv6 address in the theoretical section. And just to make it more clear, there are two things I'll be showing you on the lab as of now. It's like not a complicated lab. I'll show you a basic lab about static, or you can say how you can deploy IPv6 over the devices. So there are two ways to write IPv6. You can define IPv6 statically, either you can go dynamically. So to define statically, directly you are going to execute the IP address on the devices. And when I say dynamic, so dynamic is something that the device gets the MAC address by using the DHCP server. So there are other things like we have some stateful and stateless configurations in IPv6. That part we'll see. So I hope up to this part, everything is clear to every one of you. If you do have any questions, so you can use the chat box. Meanwhile, I'm sharing my lab screen. to show you a basic deployment of IPv6, that how we are going to deploy IPv6. Yes, Anurag, we will offer you some files to install your labs. Like in CCNA trainings, packet tracer is the only requirement, and it's all about we can complete the lab on packet tracer. But when you will be going towards the CCNP trainings and CCNP and RCN core trainings, there we provide you simulators like EvenG and all these things from our end, so that you can access your labs on that. So I'm opening up my packet tracer as of now, just to show you a deployment, how basically it is going to work and how we are going to, execute or deploy the IPv6 address.
Hi. So till Jatin is doing the quick setup. Any questions, guys? Anyone has regarding CCNA training, or if you're already in touch with anyone from our team, or you want to know anything related to jobs, placements, and other thing, anything like that? Okay, Anurag, please, you can unmute yourself. I think we have given the access.
So, quick question: how long would be the training, and what's the schedule look like?
So CCNA training over the weekends, which is how it is starting next weekend. I feel 20th of May. So next Saturday, it should be not more than 6 to 7 weekends. Okay.
Sure.
Over weekdays, if you want to go, let's say 8 a.m. batch or 8:30 p.m. evening batch, if you want to go on weekdays, it should not be more than 4 to 5 weeks. Okay.
And how long would be the classes are?
Every day 2.5 2 hours is minimum that will be there, and depending on topic, let's say if there is a topic which is ongoing and it's a big topic and there are a lot of doubts coming in, it could be 2.5 3 hours also. Okay, max time is 3 hours, but anywhere between 2 to 3 hours.
And one more thing, because I live in the central time, so sometimes what's the the timing is going to be a little bit challenging for me, because if let's say you're starting at 10:30, it's going and the classes goes for a couple hours, it's going to be almost like a midnight for me. So what is the earliest? I mean, are there any classes where you start at early morning or late in the evening? Because waking up in the morning, it's fine, but keeping myself awake till the middle of the night, it's going to be a little bit hard.
Understood. So I think I'll suggest you one thing, that you can either go for a weekdays batch that would be at 8 a.m. in the morning. Okay. So 8 a.m. batches are generally on weekdays. So I think that Indian time. So that would be, I think, around, if I'm converting 8 a.m. IS to CST, it would be 9:30 p.m. for you. Okay. Because our
Right.
weekend batches starts from 9 a.m. only. And meanwhile, I'm checking one more batch. One second, 8:30 p.m. Okay, 8:30 p.m. IST would be around, for you, it would be morning, right? 10 a.m. But by 10 a.m. you have to start your work, correct?
Right. I mean, yes.
Your office 10 a.m. CST. You have to start the office, right?
Oh, I usually, I mean, that's not an issue. The office is not an issue. Because I usually log in at 6:30 or 7 in the morning, and then I work till 3 4. I mean, depend on the work, but sometimes I can come out up by afternoon as well. So there is no set schedule for me to work, but it's
That's fine.
mostly, I mean, yeah, I mean, the evenings are a little bit, sometimes I have to take my daughter, and there are some other chores in the house. So yeah.
Understood. No, makes sense. Understood. So what we'll do, I think you are connected to Ayushman parallelly, right? Personally, you're connected to Ayushman.
Yes.
So I think I'll request Ayushman to help you out personally later on, maybe after this session sometimes. Okay.
Sure. Sounds good.
Yeah. All right. Okay. Farid, you have one question. Please explain user type. There is already video. Okay. Sure. Sure, Farid. So I think let Chirag or Jatin go through it once. Hi, Jayaprakash. I have given you an access to unmute your mic. If you want to ask anything, please unmute yourself.
Hi. It's not a technical question, but actually I want to know about the scope of this networking. Uh, Means going further only. Means I want to know about the scope part.
Okay.
Whether it is going to increase or how it will be, how the future of the networking will be.
Okay. So could I
It's
get
not.
a no, that's a very valid question. That's a very valid
Mhm.
question before you're jumping into any industry. So could I get a
Uh,
brief about what you're doing and what's your experience like or what your graduation is like right now, just to get a brief idea?
Actually, I have done the Bachelor of Engineering, and actually I was 2011 pass out.
Okay.
So after that,
Okay.
I was working into some kind of testing and some kind of a DQ job. So now I
Okay.
want to move into this some core field. So actually I want to know. So I want to choose a field which will have a good scope and means on that I can work.
Understood. Got it. And you want to jump into network now, correct?
Yes. Now, yes, currently, yes. So I
Okay.
want to know about the future mainly. That was the main concern,
Yeah. If you
which
speak
is
about
good.
networking future or present or the past of last, maybe 20-25 years, and considering that you have good CCNA, CCNP, or maybe high-end knowledge of SD-WAN, network automation, and other things. So, you, I mean, it's always an ongoing and increasing future. So, people we have, like I'll give you an example. So, we have seen people who have started from 20-25,000, and within 2 years, 3 years, they were able to jump around 45,000, 50,000, 60,000 salaries as well. In India, I'm speaking specifically. Okay. So there is an average 20%, 25% increment that you see in an year. Okay, if you're learning good, this is just a very basic example I'm giving. Okay. However, we have also seen people who have 5, 6 years of experience and good network understanding. Because see, any industry you go to, be it a software testing industry, be it a software or a development industry or network industry, any industry you go to, if you keep learning over the years, you can keep asking for a good jump and a good hike. Okay. Now, because your question specifically is what is the future of networking? See it from this angle. Without network, without core networks, nothing is going to exist. Like uh, I'm not saying key network is very much mandatory for anything to be operated. Obviously, a lot of things are, like even programming languages, software are also important, right? But without network, you and me, we both cannot come on a Teams call as well. Like in the backend, somewhere somehow a network is doing its own work, right? Without network, nothing is possible. No communication, no AI, nothing. At the back end, network will always be there. तो उसके बिना कुछ भी नहीं होने वाला in a very layman terms if I answer you. So future, past, even if you see last 20, 25, 30 years since people have started doing their, CCNA, Cisco launched these courses, except Cisco, even telecom or network, anything that you ask for, without it, a lot of things are not possible anymore, at least in our country or any country out there. Yeah. I hope that answers you a
Okay,
little.
yes, yeah. Thank you. Just one more question. Whether this gap will create any issue for me
That
around
is
10
what
years
I'm
of gap I
thinking.
have.
That is
Uh,
what even I'm thinking right now. I think we should speak offline
hmm,
once, one to one. You and
okay,
me, we can have a
yeah.
quick.
Okay.
Are you connected to anyone in the team right now?
Not now. Maybe I will connect. Yes.
Sure. So you can connect to Nitish or maybe somebody in the team, and we can connect because definitely it will create a problem. I won't lie to you here, and it would
Mm-hmm.
be very difficult to switch from testing background to this background, network
Okay.
background. Yeah, because of that, this 12 years that we have in between. But let's see,
Mm-hmm.
let you and me discuss that, what are the
Okay.
possibilities
Yeah.
that we can create and,
Okay.
work out
Yes.
it out.
Yes. Thank you.
Sure. And another question just came, Vinod Kumar. I think CCNA fees is simply INR 10,000 only, okay, for CCNA. For other job guarantee courses, I'll share the link here and the fees is mentioned there directly. Okay, I'll just share the link. Meanwhile, let's go technical once again.
All right, guys. So let's see a basic lab setup that how the IPv6 is being deployed inside the devices. So I'm not going to get more in detail. So just a glimpse I'm giving you here that how you can execute or deploy the IP addresses. Let's assume this is your router here. And let's say this is your router. If I'm going to start and get the CLI access. So this is a packet tracer. So simply by clicking on the device here, I'm getting the option to get the CLI. But in the real time scenarios, the thing is different when we are accessing the devices. So in the live classes, I'll be explaining you that how you are going to get the access of real-time device with what are the software which we need to install to get the CLI access, or how we can get the GUI access as well. So let's say this is the device. So this arrow sign represents a mode. We call it user mode. Then there is a command execution enable. Now I'm on the privilege mode. So I'll explain you all these modes as well in the live classes because this is a part of Cisco iOS. And we'll see that. So as of now, I'm going on the global configuration mode by using the command configure terminal. Now, as you can see, I am on the router configuration mode. So this is considered as global configuration mode of the device, where whatever the executions we are executing inside the device will be implemented and executed globally inside the device. Suppose that if I want to verify that how many interfaces are there on my device, so I can use the command show IP interface brief. So if I'll enter here, you can see there are three interfaces: gig 00, gigabit Ethernet, gigabit 01, 02. So all these are unassigned. They are having no IP address. Method status is down. So this command is used to verify the IPv4 interfaces. But let's say if I want to verify v6 interfaces, so I'll say do show IPv6 interface brief. You can see again three physical interfaces are there. They are unassigned. Like if you will go in the physical part here, and if you will zoom in the device, so you will be able to see 1, 2, 3, 4, 5 ports are there. One of the port is your console port, which is mentioned as a blue color here. You can see, if I'll show you just a moment. See guys, it is mentioned here that this is your console port. So this console port is used to access the device. This is your aux port, where these are your gig Ethernet ports where we can execute and implement the IP address. So let's go directly on the interface. Now, if I want to execute the IP, you can say on the router gig 00 interface is connected to the router number 2, or this router 0 is connected with router 1. And this side I am having gig 01 interface, which is facing towards the switch. So if I want to execute the IP on gig 01, so you will see that when I verified the command do show IP interface brief, there is no IP assigned here on the interface. So I'll say interface, and I want to select which interface. I'll say gigabit Ethernet and which number 0/1. Now I'm inside the interface, as you can see, config-interface. Now I will say IPv6 address and the address I want to execute. So if I'll put question mark here, you can see it is asking me that which IP address you want to execute. So I'll simply say this was the first command, then we'll say IPv6 address, and the address is FC00 colon 11 is there. So if I'll write 0011, that too is fine, but to make it shorter, we basically use the colon, sorry, removing the zero values here. So FC00 and then again 11 colon 11 11 double colon means continuous 8 zeros are there, 1, and the /64 represents that this is the network portion of the global prefix value. Once it is done, I'll say no shutdown, exit, and if I'll verify do show IPv6 interface brief. So you can now see that FC001111 is the IP address which I have executed on gig 01, and you can see the state of the port also changed from red to green, which means the interface is now in the up state. But you can see there is one more IP address which is executed here, which is FE80, and there is a range as well. So FE80 double colon is there. And when we discussed in the slides here, so guys see, on the slides what I told you, that there is a link local address which is default address available on every IPv6 enabled interface. So this is the link local address which is coming up, which is going to have the range of FE80. So any address that starts from FE80, that means that's the link local address. Similarly, if I'll execute the IP address on gig 00, you will be able to see that we are going to get one more link local address for a specific gig 00 as well. So I'll say interface gig 0/0. See, I have not written the complete command because it do supports auto sensing. Then I'll say IPv6 address. Then we have 2001. Then colon 12 is there. So if I'll write 0012, that is fine. 0012, 0012 double colon means 8 times 0. Or if I'll write, let's say colon 0 colon 1/64. Okay, I need to mention the IPv6 prefix as well. So I'm just removing this part because I need to put some explanations for that